Okay, let's dive right into today's explainer and explore what is genuinely one of the ocean's most bizarre and captivating creatures. We're going to unpack the exact science, the wild anatomy, and the surprising environmental realities surrounding an animal that literally looks like it was dropped here from another planet. You might want to grab your notebooks for this one, because the biology of the blue-ringed octopus is absolutely mind-blowing, and understanding it completely changes how we view marine life.
Seriously, I want you to really picture a creature whose biology defies pretty much everything we know about typical animal anatomy. If I told you there was an animal out there with 3 separate hearts pumping copper-laced blue blood, and that its esophagus passed directly through the dead center of its brain, you'd probably think I was describing a sci-fi movie monster, right? But no, this is a very real, incredibly complex inhabitant of our own oceans.
So, Part 1. Meet the blue ring. To really wrap our heads around these bizarre traits, we first need to look at the Hapalochaelaena genus.
Now, there's a brilliant little irony when we look at the 3 main species in this group. It turns out the name greater actually refers to the size of their distinct rings, not the size of their tiny little bodies. The greater blue-ringed octopus, or lunulata, has fewer but much larger rings. Meanwhile, the lesser blue ring packs in 50 to 60 much smaller rings. And then there's the fasciata, which completely ditches the rings altogether for these intense iridescent blue lines. What's truly wild here is that the ancestors of these bottom-dwelling cephalopods have been roaming the seas for over 500 million years. They were dominating the ocean depths long before fish even arrived on the scene.
You can really see the visual contrast between the species. The greater blue ring has these distinct, almost hypnotic round markings where each iridescent ring sits inside a broader dark patch. Compare that to the blue-lined octopus, which rocks these striking, pulsating streaks instead of rings. But regardless of the pattern, both of them use these bright neon blue markings as a profound warning system. They can literally shift from a dull, rock-like camouflage to this vibrant, flashing display the second they get agitated.
Moving on to Part 2, bizarre and brilliant biology. We've seen their beautiful exterior, sure, but it's what's happening under the hood that makes them a true marvel of evolutionary engineering. Let's look at how their nervous system actually operates.
So because invertebrates don't have myelin sheaths, those biological insulators that speed up nerve impulses in vertebrates like us, they had to evolve a totally different workaround. And their solution? A giant nerve fiber that's up to 1 millimeter thick. That is literally the size of a strand of spaghetti. This massive biological cable is specifically designed to trigger lightning-fast jet propulsion, which lets the octopus contract its mantle cavity and rocket away from danger in the blink of an eye.
And get this, they possess 300 million neurons, all arranged in specialized lobes. To put that massive number into perspective, that gives the octopus the most complicated brain of all invertebrates, granting them surprisingly solid memory and the ability to learn. Plus, as we touched on earlier, their digestive tract, their literal esophagus, passes right through the dead center of their brain. It's a biological setup so crazy it honestly forces us to rethink how intelligence can even be structured.
Of course, a complex brain like that needs an equally unique circulatory system to back it up. Because their blood pressure drops significantly when it travels through tiny capillaries, they evolved an absolutely incredible solution: 3 distinct hearts. It works like this. 2 dedicated branchial hearts exist purely to force unoxygenated blood directly through the gills. Then, once that blood picks up oxygen, a 3rd, main systemic heart takes over the heavy lifting, pumping that freshly oxygenated blood out to the rest of their body.
The contrast with our own bodies here is just staggering. While human blood relies on an iron-based pigment that makes it red, an octopus uses a copper-based protein called hemocyanin, meaning their blood literally flows blue. And check out the blood pressure difference. Theirs sits at a lazy 27/15. Now, while that is a tiny fraction of human blood pressure, it's actually incredibly high for a marine invertebrate. It's double the blood pressure of a lobster. It's just a completely different, yet perfectly adapted way of sustaining life.
Now just imagine this for a second. Imagine you can taste every single thing you touch with a sensitivity up to 1,000 times greater than a human, simply because your taste receptors cover your entire body. On top of that, they have excellent 360-degree vision of the world around them. But paradoxically, despite those vibrant neon warning rings they use to communicate, they are completely colorblind. Oh, and if that wasn't unique enough, they actually register smell using small specialized pits located right beneath their eyes.
All right, Part 3, the ultimate escape artist. While their internal biology is fascinating, their physical capabilities turn them into pure nightmare fuel for anyone actually trying to keep them contained.
Because they have a completely boneless anatomy, these guys are pure muscle escape artists. Without a single rigid bone to hold them back, they can flatten themselves out completely to vanish into the tiniest nooks and crannies. Because their bodies are essentially just protein-based muscle, they can push through the absolute smallest cracks. So, an aquarium canopy that easily holds your standard fish. Yeah, that'll do absolutely nothing to contain a determined blue-ringed octopus.
There's this harrowing quote from our source material by James Wood that hits the nail on the head. He talks about concluding an animal had escaped only to have it suddenly reappear right in his hands. Just imagine that. You're breaking down an empty tank, totally convinced this highly venomous animal has somehow escaped onto the floor, only to suddenly find it crawling right onto your bare skin. It is a chilling reminder of how easily they hide in plain sight, and honestly, the massive, massive risks involved in trying to domesticate them for home aquariums.
Which brings us to part 4, protecting the ocean floor. Because sadly, despite their potent venom, their high intelligence, and their incredible escape skills, humans remain their absolute biggest threat.
We are severely depleting their numbers through overcollection for the aquarium trade, and tragically, that often involves using poisons like cyanide. On top of that, they're frequently killed out of pure fear when everyday people encounter them in shallow tide pools. But perhaps the most devastating threat of all is the rampant environmental degradation of their inshore habitats. We're talking about the physical, literal crushing of the delicate reef ecosystems they rely on to survive.
When massive bottom trawlers drag heavy nets and tires across the seafloor, they completely obliterate everything in their path. The source specifically points out how these practices crush ancient Gorgonian corals near Australia that take up to 7 centuries to grow. Think about that. When we damage the living seafloor, we aren't just taking away the home of the blue-ringed octopus. We are destroying intricate, centuries-old ecosystems that might never actually fully recover.
Now, to combat this kind of destruction, major institutions developed the Seafood Watch Initiative. It's a system that brilliantly empowers us to figure out which fishing practices actually spare the seafloor. It breaks our consumer choices down into 3 super simple categories. You've got your best choice for abundant, environmentally friendly methods, then there's proceed with caution for methods that carry some habitat risks, and finally, avoid for seafood that's overfished or caught using methods like bottom trolling that actively harm marine life. By simply using a Seafood Watch wallet card or the app, you directly support habitat-friendly fishing methods. We're talking about practices like trap fishing or longlining that don't just bulldoze the ocean floor. It seems like a small everyday action, right? But it ensures that those fragile, rocky reefs and ancient corals remain intact, literally guaranteeing that creatures like the blue-ringed octopus will still have a place to call home tomorrow.
So I'm going to leave you with this final, really provocative thought straight from our source material. The challenge for us, whether we're talking about massive aquariums or just everyday individuals, is to deeply consider how our daily choices impact the survival of these alien wonders of the deep. When it comes to marine wildlife, are you a net consumer or are you a net producer? Are our actions actively taking from the ocean, or are we helping to protect and produce a healthier marine environment? I want you to really think about that the next time you find yourself marveling at the bizarre, brilliant biology of the blue-ringed octopus.